Good day, everyone. How are you guys doing?
I'm fine.
Yeah, Mr. Nkwocha.
Good afternoon.
Yeah, we are good.
Yeah, I can see some SS3 boys there. SS3, there's no lesson for you guys again today. We can't prepare for your meeting with the president. Unless you want to join SS2 students and do their chemistry. So
Mr. Nkwocha, I thought that the president's meeting was tomorrow by 8 o'clock.
no, the normal meeting with you guys now. That one is for parents now. Your meeting with president
Wait,
is,
the one for tomorrow is for parents.
yes. So your meeting with president today.
Oh, thank God. Thank you, Jesus. Okay.
So you meet with the president today. My parents one is tomorrow. Unless you want to enjoy more, learn more from SS2 people. Yeah,
Don't worry, sir. I'm fine with it.
okay, yeah, no problem. So SS2 chemistry people, yeah, welcome.
Yes,
So
sir, it seems like this is SS3.
this is SS2. I'm not teaching SS3 today. So unless you want to learn revise
Eh?
Akano.
Look at your participants. So you're seeing SS3 as well.
And you guys want to learn none, you stay and learn chemistry. That's what I know. If you want to learn, I shall know that SS3 and SS2 is the same time. But yesterday I told SS2 I will be taking them because last week I didn't take you guys because of your meeting with the president. So and your meeting will start by 1 and I cannot come and kill myself. So if SS3 guys want to enjoy the chemistry, good luck to them.
Yes, sir, just send me the video of this class. Send me the video of this class.
I'm not sending you can stay and listen to the lesson if you want.
But sir, data for the
You know how many MBs you take? Like 70 MB. I don't have that kind of strength. Anyway, ladies and gentlemen, welcome to the chemistry once again, and it's good to see all of you here. As usual, keep your mics under check and be at your best. You are free to unmute yourself when you feel like contributing to the lesson, and also you can use the chat section. Okay, to ease your contribution. I hope you have been practicing the Viative. You have been practicing on the Viative platform. So we revise our canals and we continue from where Mr. Fayemi stopped yesterday. Okay. So yesterday, sincerely, network was not really my best friend. I couldn't imagine. I just couldn't imagine. So I did everything right. Was we just thank God that today network is showing us some kind of favor. All right. So yesterday, Mr. Fayemi talked about. I will not bother talking about all these types of arcanas. So unless, please, you guys, please, every lesson is very, very important. So don't assume that we are still going to resume third term and we are going to do all this thing. The probability of us doing third term is, I don't know, is very low. So even if I go to do third term, it will be just for about maybe 3 weeks or 4. So some people will say, I will not do online lesson. So let me just stay away from online lessons. The teacher will teach you later. You're not helping yourself. Okay, so please make sure that you are available in all lessons, no matter how easy you think the subject is. Okay. All right, so I'll just take a quick review from here that Mr. Fayemi did yesterday. It's not last the most I don't want to say the most important. This is like we use it as a representative member for the alkanols. Okay, so the other one is methanol. Methanol is the first member. After methanol, you now have ethanol. Okay, so for me, I've worked with both of them. I work with methanol, I work with ethanol. Both of them are used as solvents. I remember somebody asking that question yesterday. Can they be used as solvents? Both of them, are they solvents? Yes. The answer to that question is yes, they are solvents. And if you want to dissolve some organic compounds, so you obviously have to use methanol. Okay, so dissolving some organic compounds it means that we have to use methanol. And guy, just join the class, and learn whatever we are learning. It's the same thing. It says two students, so you can continue with the lesson if you don't mind. It's still the same chemistry, so rule on. Okay, so you take it as a revision. All right, thank you, SS3. I'm not chasing you, we just stay and continue the lesson. All right, SS2 people are learning it afresh. Okay, so no big deal. But I can see majority of the students are SS2, so but no big deal. All right, so okay, so I alkanols or ethanol specifically can be prepared in the lab and also in the industry. Now, hydrolysis, can you remember this word? This is hydrolysis. What does hydrolysis mean? Hydrolysis means what? You can use a simple word to describe hydrolysis. Quickly, use a simple word to describe hydrolysis. I don't want to say, just what other word can you use to describe hydrolysis? I need a very simple word. Type it on the chat section. One word, just one word. Come on, guys. One word can you use to describe hydrolysis? I'm listening. Come on. You've done this thing before, so addition of hydrogen. Okay, I got addition of hydrogen. Okay, I think one word. Okay, well, for me, one word to describe hydrolysis is as simple as what I'm going to write on the screen. Breakdown. Yes, one word to describe hydrolysis is breakdown. So if you break down iodoethane with an alkali, very simple. If you break down esters with a hot alkali, that's very, very simple. What do you mean by iodoethane? You know, ethane is what? C2H6. So, but if it is iodo, that means the iodine has replaced one of the hydrogen. So if you break it down with an alkali, let's say for example of an alkali, can give us sodium hydroxide. Sodium hydroxide is an alkali. So if you let's break it down, let's take away. Remember this organic chemistry as this is positive and iodine is negative, so both of them will react. This is to the positive and the other one is negative, so both of them react. You can see that's very easy. Okay, so if you react, so you now have C2H5OH, very simple, plus NEI. Okay, so that's very, very easy for you to recall. Hydrolysis of what? Iodoethane. So you have broken down that iodoethane, and one of the products is what? Is an alkanol. So which is ethanol. You see? Very, very simple. Okay, so they talk about the other one, hydrolysis of ethyl esters. You guys, you guys may not be able to know what ethyl esters. So SS2 students, so no big deal. Let me just tell you what an ester is. An ester is a organic compound responsible for what I call it, the sweet smell. Yeah, the sweet smell in most fruits. When you take banana, mango, uh, orange. So those the sweet smell that you perceive in those plants, they're usually ester. So the third one is an ethyl ester. So ester, let's say for example, C3. Let me use the word C3H7. So SS2 should be able to talk about this. COO. Then you now have ethyl on the right hand side. Ethyl is C2H5. So you break it down. They say again with the hot alkali. As simple as it is. So you're writing with an alkali, sodium hydroxide. See, life is easy. So don't assume that these things are very difficult to do. So you break it down. Obviously, it will be broken at where? At the C2H5 component. So you have C2H5 with the OH from the alkali. Remember that? Then obviously they now have C3H7 COO. Then you have your, what is that one? Na. So that's another chemical reaction that you are doing. So, but if we want to do if you prepare it in the lab, you can see we have two products here. So both of them are liquid. So sodium propanoate, sodium butanoate is a liquid, and ethanol is also a liquid. So you also obviously have to separate it. So is this SS2? Both is both. Thank you. Optional for SS3, compulsory for SS2. So you can see this compound here now, sodium ethanol. Sodium, this is ethanol here. Then you have sodium butanoate. So because we have two liquids here, you obviously have to separate it. So separating it in the lab, you have to do refluxing, or is that there's what we call refluxing, or also there's what we call distillation. So because you have two liquids, the easiest thing to do is to do a distillation. But comparing their boiling point, we prefer to do fractional distillation. I'm sure you've all seen the setup of fractional distillation in this school. If you haven't seen it, if you resume, please come to the lab and you see it. I will help you. I'll set it up. I'll also do it for you. Okay, so that is fractional distillation. Because the reason is because they have close boiling points. Okay, so that is it. But why do I have to be preparing alkanol in the lab when it can easily be prepared locally, even in your house or at home? How can I prepare locally from different ways? It's usually called fermentation. So local method is called fermentation. So under this fermentation, remember for SS2 students, fermentation could be a new word. But for those of you offering biology, it can never be a new word, I trust. But for those of us in SS3, fermentation can never be a new word. All right. So here, fermentation means that it's like slow decomposition. So I want to use this word again. Fermentation can also mean breakdown. Another word for fermentation can still be breakdown. So here, but this, you see, when we did hydrolysis, we use an alkali. That means we are breaking down iodoethane or ester with an alkali. We can also use hot water. We can also use acid. So here, but under fermentation, the breakdown is not by hot water, it's not by an alkali, but microorganisms like enzymes. Microorganisms like enzymes. Okay, so very, very important. All right, so are we meant to memorize the ESTA formula, my dear boy? That will just be coming up. Yes, not cramming. You can't memorize it. You get to know it because after alkanols, in fact, here today we should be able to talk about esters because after alkanols, the next topic is esters. Esters is another homologous family that we are supposed to learn. So you can imagine how big organic chemistry and how wide organic chemistry is. So we are still going down all the way to talk about esters. So it's important we also learn it. Okay, so under this industrial preparation, so we have from ethene, I also have from um, starchy food, which you describe as fermentation. So here is the product I talk about reaction of an ethene with steam. So you can see here hydration. So you talk about hydration. So you can see hydration. You can see this